All right, why don't we get started? My name is Grant Ingersoll. Welcome. I'm going to be talking today about crowdsourced intelligence and how you can build this into search and how you can leverage this in a big data environment. If you've been to any of the earlier talks about recommendations, search, etc., a lot of the concepts here are essentially trying to take and look at more generic forms of that, not just recommendations, but how can we leverage all this feedback that we get from users to make for better search, better data access, those kinds of things, okay? So I want to start off by asking some questions, really hopefully getting you to think about, is search enough? If you've been using Lucene or Solr or Elasticsearch or Decay or GSA or whatever search engine technology you've been using for a long period of time, you know that you can get really good keyword-based search out of those, right? But then you start to ask yourself, is that enough? How many of you are doing ranking just based off of keyword matching, kind of good old tried and true TF-IDF? A few people. How many are using other factors, user profiles, ratings, reviews, recommendations, et cetera, right? So when you look at, so there's a handful of you, when you look at the big boys in search, right, the Googles, the Bings, et cetera, from what I've seen and gathered from looking at literature and what people publish, et cetera, they use on average somewhere between 500 and 1,000 different features just to score your query, right? So this is things like your social network activities, obviously things like PageRank and authoritative calculations, the TF-IDF scores, et cetera, all of these things factor in, and that's really what, in many ways, I want to talk about here. The other thing I want you to think about in the context of search, and the reason why I have these background of clocks here, is I want you to think about this intelligence stuff, this crowdsourced intelligence, how to leverage this as a way for you to improve the capabilities of your search while also hopefully compressing the amount of time it takes you to build a quality search application, right? So if you think about what it takes to build out a quality search-based application, right, you have this upfront part of the time, say it's a 6-month project that's gonna roughly take to do this. You have this upfront part of the time where you're gonna go off and you're gonna do your technology due diligence. You're gonna look at Lucene, you're gonna look at Solr, you're gonna look at any of the other competitors, et cetera, and then you're gonna make some selection about that thing, right? And you're gonna say, oh, well, this is the search technology I need, and it's based off of Lucene, and that's tried and true, and that's all great. We, of course, want you to do those things. But then you're going to spend maybe the next month out of that 6 months doing the dirty work, right, of how do I get my data in, how do I get my analysis stream done right, how do I make sure this thing actually stands up in a QA environment, et cetera. And then you're going to, in all likelihood, spend all of the rest of your time, and from here on out for a while, how do I actually improve the quality of my data access? Right? Am I getting my users the relevant, am I getting them the best results I can get them in the situation I'm in? I'm sure if most of you are engineers, I can speak from experience on this. On more than one occasion, I've worked my butt off. I've been on weekends. I come in and I think I've got search all ready to go. Boss man comes in, CEO comes in. Oh, I did a search for X and the results stink. Your search is broken. And now all of a sudden, I'm in this quandary of, search is not broken, I know it's not, but I can't even necessarily prove it back to him because I don't have this bigger picture view of it's not just about deploying the technology, it's about deploying the technology to effectively solve the problems that the business needs to solve. And that's where I think this stuff around crowdsourced intelligence can really help you solve those kinds of problems such that you can go back to boss man and say, hey, you know, I'm sorry that your query doesn't work out for you, but here's the list of 50 queries that we make all of our money off of, and those all work. Right? And that's what matters. And so that's why I ask you, is search enough? I think you need to start to think about a lot of different things when it comes into search. Obviously, like I said, keyword search is a commodity, but at the end of the day, you need to take a much more holistic view of not only the data you have, the search technology it's in, but also how are users interacting with that data, right? So if you were down at Robert and Simon's talks, you saw how some of this stuff factors into auto-suggest. That's one avenue of this, spell checking, recommendations, et cetera, et cetera. These are all specific instances of ways that you can leverage this in a much more interesting way to provide, at the end of the day, those better results that you're after. The last part I would make at this high level is I think really the key to unlocking all of this is you have to move well beyond search. And this is where it starts to get interesting when you combine search and Hadoop, because Hadoop provides you this great capability for essentially mining all of the logs, mining all the information you have at scale in an offline mode, doing all kinds of fancy machine learning or statistical analysis, and then you can push that back into Solr, you can push that back into your search engine. And this is by taking this holistic view of not only the users and the data, but also that I not only want to have users do search, but I want them to also be able to discover things, and then I want to be able to understand what they did. That's really the keys to a lot of these different things in my view. So with that introduction, what I wanted to talk about then is really just get into what are some of the details around this. What is this search revolution going on? How can we leverage the search engine that we're all used to using for keyword-based search, et cetera, to do this reflected intelligence kinds of things? How can we look at, and then can we look at some of the use cases around reflective intelligence? This is kind of a made-up term that Ted Dunning and I have put out there on a number of occasions. Things like collective intelligence, also fit into this, crowdsourcing, yada, yada, yada. So what are some of the use cases that we've seen in practice where real people are being successful with this at very large scales? And then what does it look like to build out an actual platform that allows you to do these kinds of things? And then we'll talk about why this is, finish up hopefully with some insight into why this is really beneficial. So if you're like me, most people here, you're developers, chances are you probably only look at search and your data from this layer up. If you think about it, if I've got a bunch of data and I'm a sysadmin, well, I just probably need like a distributed file system. I'm just looking at where does all this data reside? Is it replicated properly? Is it backed up, et cetera, et cetera? I don't necessarily care about the actual data. If you're the engineer who's actually implementing this stuff, well, you probably are just going to be interacting with either on the command line via some query client or maybe through your browser making REST API calls, et cetera. So you really just need things like good key value lookup, and you need to be able to sanity check all of your data, et cetera. But then when you get to be the end user, it all kinds of shifts, right? If you're like most of my users, most of them don't know how to write SQL queries. They're not going to write REST JSON calls, et cetera. They want to be able to type in keywords into a search box, right? I often ask the audience, it won't work here, but I'll often ask the audience where it's a more of a mix of business and technical, how many of you know how to write SQL, right? Now, in this audience, yeah, probably most of you. But in the audiences I often talk to that are more business-oriented, it's maybe one or two people. And I say, well, how many of you know how to type in keywords into a search box, right? And everybody in the room goes up because as a matter of fact, at the end of the day, search is the way we are all used to accessing data. But as I hopefully will prove out in this talk is I think you're going to see that just doing keyword search is not enough. And so when we're really looking at this notion of reflected intelligence, I think this is where we're talking about is how can we bring this back to the user? These people, they don't care so much. They just want to make sure everything works and it works fast. But those end users, this is really where we're talking about how do we bring this up a level. So the other interesting thing that I think is going on, and probably in many reasons why a lot of you are here, both at this talk and at the conference, is there's really a revolution going on in my mind, or maybe an evolution. It depends on your point of view of how long you've been doing this, but there's really a revolution going on in search. And I think the interesting thing is in no small part comes out of the NoSQL movement, or this movement in my mind of where computer scientists finally remembered why they went and got that computer science degree, because it's not all about just looking up things in a database. It's like, oh, hey, you know, I took this class on algorithms, or I took this class on data structures. Maybe I should use the appropriate data structure for the job, or the appropriate algorithm for the job. So one of the things I hopefully can communicate to you here today is that search engines, the actual algorithms and data structures, are pretty interesting for solving all kinds of problems, not just related to search. So in fact, when you think about a search engine, what is it really good at? It's really good at returning top N. Right? That's what it's optimized for. It doesn't necessarily have to be based off of human language, what you put into it. At the end of the day, Lucene, it's not like it calls the things that it puts into the index words. It calls them tokens. And the reason is a token is an abstract concept. So you as an engineer, you can think about all kinds of things that you can put into the search engine. Like Ted talked about this morning, you can do it with co-occurrence information such that you're just putting in data around what people have clicked on. You're not necessarily putting into it the actual tokens, etc. A few ideas around this that really crystallize my thinking. One is this notion of, as soon as you start putting data into search, you often go through this process of denormalizing the data to some extent. Now, Lucene and Solr, et cetera, have gotten better over the years of dealing with some level of normality when it comes to the data. But the fact is you're often denormalizing your data from its third normal form, or whatever you keep it in the database, or wherever it originally came from. But once you start doing that, you start to see, oh, there's all kinds of different ways I can access this data that makes for a much more friendly experience for my users, and a much more responsive way of users interacting with it. The other thing that comes to mind is that, and Ted said this to me one day in an offhand comment, like, isn't it obvious? Now, I don't know about you, but whenever I hear Ted talk, it always takes me about 3 days to really understand what he said. But when I finally get there, it's like, gee, he's really right. And the thing he said to me is, well, if you think about scoring in a search engine, it's really just a sparse matrix multiplication, right? Well, and then you say, okay, well, yeah, that makes sense after a while. And then once you realize that, you realize, well, I know a whole bunch of other kinds of problems that are sparse matrix multiplications, right? And so then you say, oh, well, maybe I can use a search engine to solve that. Because again, it's not so much the idea that it's a search engine, it's the idea that the data structures and algorithms that are used to implement a search engine also can solve these other kinds of problems. The other thing that's been going on, if you haven't been paying attention, is, you know, Lucene 4 is not Doug Cutting's Lucene anymore, to put it nicely, right? What was Lucene 3 and 2 and 1, et cetera, that has changed quite extensively. We've got things like joins in there. We've got a lot more database-like features. I like to think of search as being NoSQL before NoSQL was cool. You've also got things like flexible indexing, if you've heard of any of the stuff around codecs and posting lists and all of that kind of stuff. A lot more flexibility there. And then if you were in Simon and Robert's talks, you know these FST things are pretty cool too, so there's lots of kinds of problems we can solve with those. And then other things that come to mind is this stuff scales way better than it ever did. It was pretty fast back when I got started with Lucene relative to the time that we were at, but nowadays I think it can keep up with almost everything that you want to throw at it. And more importantly also, and especially in the context of search, it's not just about keyword-based stuff. We've tried to bake in more capabilities that allow you to do fancier relevance. We've also made it easier for you to try out alternate relevance models. So all of those things hopefully allow you to think about, there are ways that I can use this stuff to solve these kinds of problems. So getting back into the reflected intelligence a bit more, I start, like I said, like to think about it in the context of search, discovery, and analytics. And when you really think about this reflected intelligence, it's really all about large-scale analysis of what users are doing with your content. I often think that many reasons why things like enterprise search, et cetera, often fail within a business is not because the core search technology isn't good. And for the most part, the underpinnings of any of these search engines is more or less the same and has been the same for the last 30 to 40 years. The thing that is often missing is that they don't take account for what users are doing with that data, right? And so this is where you start to do things like really looking at correlation analysis, looking at what are people querying for within a session, within a day, within a week. What are they clicking on? Some companies I know actually are now tracking where you are on the screen, and they will send that back all the time such that you can know where is the mouse hotspot is for any given query. So because oftentimes clicks aren't exactly a good predictor of search, because if you've done a good job of highlighting or snippet generation, it may be that the user gets their answer solely by looking at the screen, and so you never even get a click. But if you know where the mouse is on the screen, chances are you saw they scrolled down and were hovering over a certain place. So all of those things can feed in and really help us do this large-scale correlation analysis. And then there's lots of other things you can generate out of this, things like clusters, trends, topics. SIPS stands for statistically interesting phrases. All of these things are the things that we're after. We're looking at not only the content at scale for interesting patterns, but also the way users are interacting with it. The other thing that comes out of this that's pretty interesting, I think, is that you can start to think about, again, that idea that denormalization frees your mind. I also think when you start to have these tools of really baking into the development of your application, this notion of reflected intelligence, you take a much more experimental approach right from the get-go, right? So you're starting to see this more and more, especially I think at e-commerce sites. I think often lead the way when it comes to these kinds of things, but you're seeing it more and more places where essentially instead of you thinking about relevance as being this quasi-static thing of, you know, I've got relevance for a week or 2 months or whatever it is, even though my data is changing, my scoring model is not, and that's typically how Lucene does it. You start to see companies actually who are experimenting with all of their relevant stuff on a daily or weekly basis. And it's not just about tracking, it's not just about doing things like A/B testing, but they're actually doing A, B, C, D, E, F, G, and they're tracking all of those experiments all the time such that, you know, some sliver, chances are no two people are exactly seeing the same site even though they put in the same queries. All the time, right? And so if you start and take that to the nth degree, we now have an even bigger analysis problem because we want to know who did what with what experiment. And so now you also need to bake in right from the get-go good version management around your experimentation. And then last but not least, I think one of the other trends you're seeing in many ways comes out of the developer environment or out of the developer movement around Agile is also take an Agile approach to your data, right? This data, even if it's coming in very rapidly, you shouldn't think about it, oh, well, I always have to analyze it this specific way for the next 3 months. You can start to think about how can I always be testing my assumptions about the data, about the way users are interacting with it. How can I then learn from that in a very rapid way, right? Because that is ultimately what leads to what I like to capture here is kind of this virtuous cycle where the more people do search and discovery, those are basically two sides of the same coin, the better analytics I get, the better analytics I get, the better search and discovery I get. And oh, by the way, doing all this analytics, this is really going to drive your business insight too, because you can siphon off all of that information and know all of those things as well to give to your business users, et cetera, so that you know what your top queries are, top terms, top usages, all of those kinds of things. So shifting gears a little bit, some of the use cases we've seen of people either experimenting with these ideas or putting them in production. This first one was a pretty interesting one around social media analysis at a telecom company, actually based in Japan. And it wasn't your typical kind of, or at least in my mind, boring sentiment analysis of tweets kind of application. This was actually a really interesting production usage or attempt at better understanding what's going on in their telecom network based off of what people are seeing in social media. So, for instance, if you're a telecom provider, you often see these spikes in usage, right? Where there's a concert or something like that, right? And so if you're looking at the social media stream there, you would see people saying, oh, I just got out of the Beyonce concert or whoever the latest pop star is, which is interesting, but doesn't really warrant you waking up any engineers to say, hey, we've got a problem with our cell tower right next to that stadium. On the other hand, if you're watching all of that social streaming data and you're noticing that you have a spike and all of the tweets are, oh my God, there's a tornado about to hit, or there's a typhoon going on, or there's a fire, or there's some other natural disaster, or something like that. Not only can you be proactive about making sure that you can provision resources to that area, but you can also probably even be a good citizen and go tell the proper authorities, et cetera, such that you can respond to it in a much faster way. And the interesting thing there is you're looking at all of that collective intelligence of people, and you're combining that in with your search system, et cetera, such that people who are watching and analyzing this stuff can see all of those things going on. And so at the end of the day, you get a much better ability to predict outages, handle emergency situations, et cetera, right? And so again, this is an interesting one because they're actually using the search engine to surface this information, but they're not really typing in queries ever. There's nobody sitting there, oh, is there an earthquake going on, and then hitting the button every 3 minutes to see if there's something going on there. Another interesting one is when you start to really look at this notion of provenance, i.e. who owns the data, and whether that data is valuable on its own or whether it's valuable because we know where it came from, et cetera. And so when you often look at broadcast-based media, TV, radio, et cetera, you never really know whether a user is going to, is affected by that advertising, et cetera. But if we're a company who's doing social media analysis, looking at the way people are interacting with that data, and then also looking at the resolution of that social traffic, you can start to all of a sudden bring all of this provenance back such that in this particular case, the advertiser found that, or the person that was providing the advertising platform was able to find out that this notion of knowing when and where and how effective that content was worth 5 times more than the on-targeted advertising. And that really can lead, obviously, to a lot more interesting stories when you think about it from a business standpoint. And again, the interesting thing here is that the advertiser, the platform that's providing the advertiser, they don't need to be some sentient being that knows all, right? They're just reflecting back to the people buying the ads that, hey, I know and I can count how many people are seeing this because I've got all of the things in place to do this. And the search engine technology is really good at allowing you to capture that kind of information along with these offline analytics. Another interesting one to get a little more enterprisey on you and not be social media oriented. Looking at claims analysis at an insurance company. So typical kind of thing here is you've got you've got a lot of metadata. Where was the accident, make, model, year, all of that kind of stuff. And then usually you have a whole bunch of text data along with that. Things like eyewitness reports and police reports, et cetera, et cetera. And in this particular case, what was really interesting is that this insurance company, this is a pretty large US-based insurance company, they were able to combine free text search with a lot of metadata analysis to really identify high-risk activities across the country, also to do things like fraud analysis, et cetera. And the interesting part there is that oftentimes for instance, in these fraud analytics systems, you have this kind of combination of 2 things going on. You usually have a machine learning based approach for doing fraud analytics, but some percentage of the cases you will not be able to handle just by a machine learning based approach, and so those you kick out to the human and then they have to go and investigate. And one of the best ways in this particular case we gave them to allow them to investigate was by giving them a search interface on this that not only incorporated the machine learning aspects in ratings and recommendations, but also their colleagues' ratings and recommendations on the case if they happen to be collaborating, and then their own judgment could be brought back into that. So it's not necessarily reflected intelligence at a large scale, but it's within an enterprise, I think, is reflecting more and more of that intelligence in there, such that at the end of the day, Questions that used to take them 48 hours at most to answer now take seconds because, again, we're doing all this offline analysis of the data, and then we're pushing it out through the search engine, which is that natural interface for a given customer. Another one real quickly, can search catch bad guys. This is another customer of ours doing online drug counterfeit detection. I don't know if you know this, but a lot of online pharmacies, at least as far as US law goes, they're selling drugs illegally because the pharmaceutical companies do not authorize them to sell online. And so there can be a lot of problems there. But as a pharmaceutical company, you don't necessarily have the resources to go after all of these guys, or you don't have the ability to just go across and take a shotgun approach. And so what we tried to do in this particular case was working to essentially create a vertical data set around these online pharmacies, get in and identify commonly used language indicators of counterfeit activity, right? So the idea being here is that the way all of these different websites talk about how they're selling these drugs in an online pharmacy situation, there's often good indicators in that, but you wouldn't know it if you just looked at any single website. So in this way, it's not all of us people voting, but it's all of the authors of the content who are voting, and then you're trying to identify those patterns. So things like statistically interesting phrases become more prevalent here. People familiar with statistically interesting phrases? So these are words that co-occur next to each other more often than what you would expect given a normal distribution, right? So that's why they're statistically interesting. It doesn't necessarily make them good phrases, but chances are they're good phrases. And so if you present that out to an analyst, they can use those phrases to then go dig into the content and see what that's all about. And then, of course, like I said, you want to feed this all back out to the search-driven application such that the analysts, at the end of the day, are able to make better decisions about what's going on. One of the things we do in LucidWorks Search is fairly lightweight version of learning to rank, but it's essentially reflecting back intelligence by looking at clicks. Pretty common thing to do these days. We've baked it in. But essentially, like I said, we're trying to get beyond TF-IDF by leveraging user votes, i.e., how many people clicked for the third result for this given query? Can we go and boost that up, right? Because if you're in many situations, like say e-commerce is a good example of this, they often pay 5, 10, 20 people, depending on the size of the e-commerce site, maybe even more, to actually look at relevance on a regular basis, and they're curating the results. Little did you know that when somebody says sort by most relevant on Amazon or whatever, well, that's most relevant to who? Well, it's most relevant to probably your query and to what Amazon makes off of you. So they're going to give you results, all else being equal. I want to give you good results that I make more money off of, right? So one of the things that you can perhaps do in those kinds of situations also, so that you can reduce the number of merchandisers you have, is just simply let the popularity of the results be the factor in scoring. So it's not just the keyword matching, but also how many people went through and voted on this. And so the way we do this, of course, in our system is, of course, you've got to log all the clicks on the query. You can't get by without any of that. And then periodically, you process the logs. This is not necessarily something you care about in real time, unless maybe you're a flash sales site where the sale could be done in 5 minutes. But generally speaking, popularity doesn't change that often, and so you can do this hourly or daily or weekly kind of situation. And then what we do is some trickery underneath the hood to update the Lucene index such that you don't have to go and re-index all of the documents with these boost factors. Some of the other things you can do around learning to rank is, of course, train a classifier, etc. If you're really interested in learning to rank, there's a lot of interesting academic literature about that. Not that hard to integrate in with Lucene. And then hopefully at the end of the day, you profit. The other thing you want to watch out for is things that are popular tend to stay popular. So you want to also think about how can I decay this over time, such that new content has a chance to become popular. Looking at this a little bit, I borrowed this slide from Andre, a previous talk from Andre. Hopefully it shows up there all right. This is just kind of some of the examples of, if you're familiar with Lucene low-level things, there's this thing called the parallel reader, which allows you to have two side-by-side indexes, presumably one that you're updating frequently and the other that you're updating much less frequently. And so you can keep track of things in, like if you have really large fields, you would keep them in the less frequently updated one, but then if you have rankings or ratings, you can keep them in the smaller one that you update. And so this is kind of capturing what's going on there in terms of how you can use this thing to look at all of the different clicks and then map that into the main index. And at the end of the day, you get back out these boosts. There's some tricks that you want to do here to be smart around it, because one of the caveats of the some of the caveats around the parallel reader is it can be complicated and fragile. You actually have to rebuild that small index in its entirety in order such that the doc IDs, the Lucene doc IDs, line up. And so there's not really any tools to manage this stuff in Solr, et cetera. But this is something we've done as an add-on capability. Another example, this is a US-based university, Virginia Tech. One of the nice stories I like out of this, if you're familiar with the Virginia Tech school shootings, one of the outcomes on the positive side was that a bunch of the professors at Virginia Tech got together and said, well, how can we help people who are going through this in the future? And one of the things to come out of that was this project called CTRNet, Crisis Tragedy Recovery Network. And what they do is this, one of the professors there is one of the legends in information retrieval, and he put together a grant proposal that said, anytime one of these events happens, let's go out and grab as much public data as we can about that event. So essentially you're creating a vertical search engine. And what they then do is they go and index all of that data immediately so that it's searchable right away, because that's often one of the keys. People want this real-time ad hoc access. So make it searchable right away. And then in the background, let's do this whole enrichment process. What can we learn about this data? What can we learn about what people are tweeting and blogging, et cetera, et cetera? And so that's really where this large-scale analysis comes in, and where they start to look at what are the relationships that are happening in this data and with users with that data, with the ultimate goal being that you can provide first responders, governments, victims, families of victims, et cetera, much more information about what happened during that event. So hopefully, at the end of the day, we all come out with a better response, less tragedy, et cetera. Real quickly, this is one of Ted's. I don't know this one in depth, but at the end of the day, I think if you went to his talk earlier, this is a classic example of search abuse, if you will. Ted at VO was doing this notion of cross recommendations, essentially putting all of the information about what people are clicking on, et cetera, into the search index, and then just asking the search engine, give me those top 10 recommendations. Works really nicely, works really well. Go look at Ted's talk from earlier. The nice thing about it is there's nobody asking questions, there's nobody typing in keywords, you're just driving these based off of the user profiles. But there is the nice bonus that you still have a search engine available to you, so now you can bring in your other fields, et cetera, with more content such that you can also ask questions of it. You can filter by location, you can filter by categories, et cetera, while still getting recommendations based off of user votes. And so at the end of the day, if you're really interested in this kind of stuff, like I said, his talk, go look at the slides online, et cetera, if you didn't see it. Houghton Mirex can help you do this, and it's also pretty straightforward to do in Solr. So those are some of the common use cases. I'd love to talk with you afterwards about what yours are. Some of the things then to think about is, okay, well, we've got these use cases. How do we generalize this? I like to think of this as you kind of have this two-part system going on, right? You want search to be, search is that, again, that interface that everybody's using. They want real-time ad hoc access to that content. And then we want to look at how can we enrich all of that data. And so this is where Hadoop comes in, doing things like big data, log analysis, et cetera. All of those kinds of things are those offline enrichment tasks. Those are really great for Hadoop and Hadoop-like technologies. If you're not familiar with log likelihood, that's another thing that it's a statistical technique that allows you to find the true anomalies in the data. That can really help you identify what are the things I really want to care about in this data, and you often need large-scale aggregate analytics around it. And then the search part is where you start to then surface all of these things. It's where all of these co-occurrences are indicators. It's where these fields combine with the metadata, et cetera, to give you back those recommendations. It can also, so you can kind of leverage it to build that recommendation engine, like has been talked about in other things. But then you can also use, like in the particular case of the click framework that we have, you can use it to do things like boosts, et cetera, such that you can also reflect that learned behavior, if you will, using more traditional Lucene techniques that you may be used to. So what do we need to do all of this stuff? How do you build one of these? Well, of course, we need fast, efficient, scalable search. If you've not been paying attention at this conference, you have good options there. You need to be able to do bulk and near real-time indexing. You need to be able to handle billions and billions of records with sub-second search and faceting, because a lot of these things, again, is how you're going to be able to let users interact with this data. And then you need to be able to do things like large-scale, cost-effective storage and processing. These logs that we all used to throw away, of course, we need to keep now. We need to be able to crunch through them all the way. And we also need to be able to join them with the aggregate, with the content itself, such that we can figure all of that stuff out together. We're often dealing with text, so for me anyways, NLP is pretty important here because I want to understand what are the things like key phrases, named entities, et cetera, in the system. Machine learning as well, so in my mind that conjures up Hadoop, for instance, or other large-scale machine learning projects, because these really are what drive the discovery and analytics side of the equation. Pig is also a great tool here. And then a few other things just from my experience of seeing what happens to people when they start to try to build this as one-offs using Hadoop and Solr, for instance, is you start to realize that there's a lot of common patterns that can be done here. Like, I need to do certain workflows on the log analysis every single time. I should be able to just drop in a pig script that adds some incremental metric, for instance, and then run it with all of my other pig scripts, such that at the end of the day I can look through that data once, hopefully, and output all of those metrics, et cetera. I also, I don't know, this is my own personal taste, but I think one of the things you really want is easy access for developers. Having to go talk to HBase and then Cassandra or Mahout and figure out all those things, as somebody who's trying to rapidly develop search-based applications, that's not a fun experience, so easy APIs are good. And then at the end of the day, I think one of the dirty secrets around big data is it's often really hard to get your data into the big data system. So things like content acquisition, et cetera, across a lot of things. All those old connectors that you maybe didn't think about in a big data context, those are still really useful. So in my mind, you end up with this, this kind of reference architecture. Of course, I've got all kinds of content going in. I've got my authoritative store here. Increasingly, this authoritative store is the search engine itself, but in not all cases or all the ways I've seen this built. This could be HBase, Cassandra, Mongo, whatever you want. And then, of course, you've got a search view. And so the reason why I said I often use the search as the document store as well is because then there's no impedance mismatch between having to keep this in sync with that, right? So if this is my, particularly with Lucene and Solr 4, et cetera, if that's my document store, then I automatically get my search view. And oh, by the way, Lucene and Solr as a key value store just on its own is really, really fast. It's maybe not Facebook fast or Google fast, but it's the rest of us fast. And so you can use that as a good key value store. So it's really easy to look up documents, and then you also get the search side of things. And then I've got this offline piece here that's doing all of that enrichment stuff. This is your Hadoop jobs, your Pig jobs, your large-scale analytics, et cetera. And then I've got a few other supporting services which are just serving up the results of these things as well, like classifications or time series information, et cetera. Because oftentimes in these situations, you want to bring in these multiple different kinds of data such that they can then be positioned back out to the user and so on and so forth. So that's kind of a general purpose framework. What we do at LucidWorks is we have a product that does a lot of that stuff, LucidWorks Big Data. In our particular implementation, We're using some of these technologies, obviously Hadoop and HBase. The interesting thing, I think, when you start to look at it from this kind of cake stack is it's all about at this layer about how do I get the data to be in the right place at the right time, right? You want it to be in the search engine when it needs to be searched, and you want it to be in Hadoop when you want to do those large-scale analytics. And then up at the top, this is on top of that, this is where you build your things like your machine learning. This is where you leverage Pig and Mahout and all of that. You tie this stuff together with a workflow engine. And then in our particular case, we just expose those kinds of APIs. Of course, this is all large-scale kind of things, so you also need to do management and know who's up and who's down and where they're located and whether they're happy, et cetera. So we, in our particular case, we use Zookeeper for this, but you can, of course, use other kinds of service discovery mechanisms like that. So what does this then lead to on the easy side of the equation? You know, there's a lot of, if you're going to do nothing else, at least start planning for how you can analyze your logs, right? So if you're not looking at your logs as part of your search engine as being critical data, then you're doing it wrong, okay? You may not be want to do it right away, but at some point in time when you get into that period beyond the initial implementation, and when the boss man is not happy with you, you're going to say, oh, I've got all that data in the logs. I was really smart. I've got it all stored already. Let me just go tell you what really matters and then implement that. This doesn't have to be done all up front, all at once. And then you want to be able to do things like make sure, one of the things we partner with MapR, one of the things I like about MapR is it's really easy to just have everything either be a file system or be a Hadoop file system. I don't have to unlearn what I've learned about file systems in the past 20 years, et cetera. And then, you know, what we do is we bake in a lot of this stuff. So at the end of the day, if you learn nothing else around reflected intelligence, and hopefully you did learn something else, I think that if you start to look at this as not just a 1 + 1 problem, but a 1 = 2, but a 1 + 1 = 3, how can I leverage all of what my users are doing to make me smarter? Then you're going to be way better off, right? Because you were the one who was smart enough to say, I'm not smart enough, I should let my users tell me what is really the good thing that's going on in my system, right? So with that, I think we've got time for a few questions. Otherwise, this is where you can get a hold of me. Happy to talk more offline. I don't have beers to offer, but I'll get you. I bought the beers last night, so consider a prepayment for your questions.